here with angle measures of polygons, and what we have in this diagram, which you probably have already written down, is we have 5 exterior angles marked in red. According to the previous theorem, we know that all 5 of those add up to 360. And so what I'm going to do here is I am going to take those angle measures and put them all together. So I've got 3x, and then I've got an x for the angle measure, and then I've got 2x, and I've also got 2x again, and I've also got 4x down here. And I know that together those 5 things equal 360, so I've got 4, 8, 11, 12x. And I know that the sum of the exterior angles of a polygon are 360. And so what I'm going to do is I'm going to say, I'm going to divide by 12. And so my x is going to be equal to 30 degrees. So what I could do is I could take this 30 and I could put it back in. I'm not going to. They don't ask me that. They ask me for finding the value of x. And so that's how I did that. So we're going to do a similar thing here on this one. Now if you want to, go ahead and pause it right here. Take this example, write it down, and try it for yourself. On the other hand, I am going to go ahead and do this right away. So here we go. So if you feel like pausing, go ahead and pause. What we need to do is we need to figure out how many angles we're actually dealing with. And I've got 1, 2, 3, 4, 5, 6, 7 sides. So there would be 7 sides, and each of them would be x because this is a regular 7-gon, as we know. And so if all of them are equal, then we're going to set 7x equal to 360. And when we do that, we are going to divide by 7 on both sides, and we get that x is approximately equal to 51.4 degrees. Now, if you're doing this at home and you don't understand that, you can go ahead and rewind. But just know that if I drew each of these as an extension out, like such, I would have 7 angles that were all equal. So this would be x, this would be x, this would be x, etc., etc., etc. Okay? So 51.4 degrees. The next problem. We're going to be doing the same thing, except this time we're doing interior angles. And so this is a home plate, near and dear to my heart as a baseball coach and as a former baseball player. Home plate. And so what we've got is we have 5 angles. And so we've got, obviously, 90, marked by the right angle sign. 90, 90. What we need to figure out is how many degrees should there be total? Well, if we do the number of sides, 5 minus 2 times 180, we get that there should be 540 degrees total. Well, we've already got 90, 90, 90, 270. So 90 times 3 is equal to 270. So we're going to subtract that. And what's left over is going to be 270 degrees. Well, since these are marked, they are equal to one another. They are congruent. Okay, so we've got 270 degrees left. We're going to divide that by 2 to get 135 degrees. Okay? Next example. We have a stage here. So if you're not a sports fan and you're a stage fan, if you're a fan of the theater, here's the stage. Now back here, these are going to be the flats that make up the background, and the front of the stage is obviously marked. Well, we're trying to figure out the angle between each of these, and notice we have 4 congruent angles. We don't know what they are, but we do have some other things here. We need to figure out how many sides there are to this shape. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon. Obviously not regular, but we're going to do 8 minus 2 times 180. And if we did those calculations, we would get that this is 1080 degrees. And we already have 90 here and 90 here. And so we're going to subtract 180. That's going to give us 900. And we're going to subtract 270. And that's going to give us 630 degrees left. I got the 270 from these two here. So I've used this, I've used this, I've used this, I've used this, and I've got 4 left. 4 angles left. Those 4 angles are congruent. And so what I'm going to do is I'm going to take 630 degrees, divide it into 4 pieces, and I'm going to get that each one of them is 157.5 degrees. Now, if you're out there on the stage and you're a stage manager, you're probably not going to measure. But if you wanted them to be equal, they would have to be 157.5 degrees each. Last example. Is it possible to have a regular polygon with interior angles of 135 degrees? So what we are saying is a regular polygon. So our formula is going to be n minus 2 times 180. That's the total degrees. And we would divide that by the number of sides because it's regular. And we want that to equal 135. Well, what we would do is we would do like we've done before. We would say I'm going to multiply by n, so I get 135n is equal to 180n minus 360. And so when I subtract 180 from both sides, 180n that is, I'm going to end up with finding at the end of this that there are 8 sides to this figure. When you come to class tomorrow, have B done. We are going to be working on that one together. That's going to be your assignment to come in with example 6, letter B done. Hope you enjoyed.